Senztek is an Australasian designer and manufacturer of clean tech technology for solar, thermal and solar PV controllers. Well, we're actually quite traditionally a software, hardware, electronics company, and our prototypes are basically done on PCB board level because we develop control technology and algorithms. However, we do package our electronics, and that's actually the area where we've just moved into, trying to have a look at different ways of presenting our products and our PCB board designs into mouldings and so forth. Well, I think one of the interesting things that we have experienced is we probably weren't as creative in our designing because we tended to keep with the same mouldings, and having the new UPS printer allows us to be more creative and entrepreneurial, allows us to conceptualize a little bit more, then do some prototypes, run out to the market, see what the market feels without huge expenditure. With regard to research, buying a 3D printer, I'm not a specialist in 3D printing. I have been aware of that technology for a long time and have looked over the years at that wonderful technology getting cheaper and cheaper. We used, of course, external bureaus in the past and so forth, and it came to a time in which I saw the UPS printer being displayed in MX, and that's where my heart was taken, and it certainly impressed me. And I had a particular project at that time, and I went to buy that, knowing very little about how the machine worked and about the complexities of the machine or the simplicity of the machine. So yeah, I've used in the past SLA and SLS prototyping forms, and they have been useful. I have to probably put this into context. The SLA is a very good product, and we still use SLA when we want certain tolerances or certain fits and bits and pieces. However, we've been absolutely blown away and impressed with regard to the tolerance and the surface finish that you can get from this 3D UPS. When we purchased the 3D UP, again, it was new for us, so we had what we would call a perceived expectation, and I'm really pleased to say that this thing has exceeded it beyond our understanding. We just could not believe how A, simple it was to use, and B, how robust it is, and the accuracy is far greater than what we imagined. Yeah, the biggest advantage that we see is our ability to be flexible. We can go out and talk to a customer now, we can get an idea from a customer, we can have internal creative sessions now, wondering how would that look, what can we do here. We do even mouldings now, where we will fiddle and have creative sessions to see if we can get certain things moulded, and we'll use the 3D UPS as the base platform for the moulding. Well, here's a typical example of a controller casing where we've had to dice up our PCB boards to fit it in a very small footprint, and we then printed off a sample to see how it looked, and got so excited about it that we made actually 5 of them and sent them off to the customer, and they're actually being used out there in the field. So that they're very strong and robust, and we enjoyed just the finish of them. Very, very good finish. So 3D UPS allows us to come up with a conceptual design. You can go and visit a customer and come back and say, yeah, we understand what we think, we understand what he's looking at. Let's put that into a 3D model, and then we can print it out now on our machine, and within a day you can be back to the customer to share with you the concept of the meeting that you had. So 3D UPS allows us to really, I think, increase our workflow through the development phase and also for production as well. We can be more creative, as I said before. We can actually conceptualize, we can hold it in our hands, we can see fits. You can do a lot of that on 3D modelling on the computer, but there's nothing like the real thing at the end of the day, and it allows us to bring to market basically our product faster and be assured that the customer is actually not going to be disappointed at the end of the day, because they've seen conceptually what this thing looks like much earlier in the development stage, and we're finishing it off further down the stage. In terms of are we impressed, probably beyond our understanding, remembering that we have an expectation when we purchase the machine that we would sort of get a certain amount of good out of the machine, and it just basically passed all our expectations. It is an incredibly robust machine. I mean, we have learnt on that machine, and it's producing fantastic parts. It is so simple to use. The finishing of those parts are to a level that we are very excited about, and we do very little finishing. But for an example, we made this section here. It's actually made in 4 pieces, so there's a join here and a join there, and we would glue that, and then we would sand just carefully those bits down there to get away the glue area, and that would be absolutely all we would have to do. Yep. So one of the great things in the accuracy about the 3D ups is that you can actually have a larger part and make it into a number of sections, and then you can glue them together. This is an example. This is made in 4 sections. Even 2 of them are glued. We also have a front casing, where again you can see it's been made in 4 sections. This was the first one that we made. So the cost of this piece here going to an external bureau was actually the cost of the machine. So everything that we've printed from the machine thereafter is basically free, from our perspective.
Well, here at Senztek, I'm mainly responsible sort of for doing the more practical bits and pieces, getting test rigs and stuff done, and also a lot of the design, the physical design work. As a designer, it gives me that extra dimension that's sometimes needed, especially with if you design in-house equipment, in-house test rigs. It is really, really useful because you don't have to get stuff made outside, and you can really design things to the need that you want. Over here we've got a little example of exactly what I've talked about in saying that, you know, it's quite useful for test rigs and something specific we want. In this case we needed a way of programming a specific PCB, and we didn't have any connectors. We were quite space constrained with that, so we designed. It was easy to design it on the 3D printer, because we could have exactly the places we wanted the pins and things connectors to be, so we can actually program that. It was really, really easy to line up. I did try that other ways by drilling the holes, but it was just not possible to have that accurate at the right places because of tolerances issues. But it's been really interesting. It was a lot more accurate than initially thought.